When your phone dies in an emergency, this tiny DIY device might be the only power you have. No batteries, no solar, no power bank, just pure muscle power. I built a compact hand generator with USB-C power delivery designed for real situations like blackouts, camping, or off-grid use. But the real question is, how practical is this actually? Can hand power really keep a modern device alive? Let's break it down. I started with a simple goal: make it small enough to fit in your pocket, but strong enough to generate real electricity. You can find links to all the parts used in the video's description. Firstly, I've used a gear motor as a power generator. The gears inside increase the rotation speed, so even slow cranking can spin the motor fast enough to create usable voltage. We are going to use a USB PD fast charging adapter module, which has an inbuilt boost converter. Due to this, the wiring will be minimal and will only require two wires. The casing and the handle are completely 3D printed. Links to these will be in the pinned comment. And while you are already there, drop a comment and let me know any other projects ideas you want me to cover. We will also be requiring one 16 mm M3 screw and its nut. This entire setup is designed to be rugged, portable, and something you could realistically carry in a survival kit. Firstly, let's connect the motor shaft to the crank handle. So we'll just simply slide it in, and now we will use our M3 nut and screw. Now let's check the voltage output using a voltmeter. We'll use these alligator clips. So we'll rotate the handle in a natural position, natural direction, which is going to be clockwise. And we have to keep in mind which side is the positive and which side is the negative. Because as we can clearly see on the board we are using, that they've clearly indicated the positive and the negative connection, and we can't connect the other way around. So please be mindful about that. So now, as we can see, we are able to get a, so the voltage was pretty much stable at around about 15 volts. So that's a good amount of output which we can easily use and output to a phone. As you can see, this board accepts a voltage from 8 to 30 volts, and we are at 15 volts. So now let's solder the cables between the PD board and the motor. So we'll take our two cables. They don't need to be that long. So we'll just cut them to size. So this soldering iron, I'm actually going to be powering up with my portable power bank. This is one of the other projects which I made. I'm going to pop a card up here in the video so you can go watch it if you want. This can do up to 120 watts. That's why it's able to power this soldering iron. It's a cool project. You can check it out if you like it. Now let's prep the PD board. We'll solder our motor terminals as well. Solder your tip before you put the soldering iron away. I'll make a video later about my guide to soldering, what I have learned over the years. We already have a hole for the type C port here, and I'm just gonna hot glue this inside here, because as we are hand cranking, it won't generate that much heat, so hot glue will suffice here. There's no need to go for an epoxy or screw. We can do it, but there's no need. So I'm just gonna use hot glue and I'm gonna fix it here. What can come in handy is to have a cable at hand. So once we stick it inside, we can plug the cable in, so we are sure that it's aligned. Now we'll just push the motor in. I made the dimensions of this casing so that we don't need any glue or anything to hold this. It's a pretty snug fit, so it won't be going anywhere. So I'm just gonna push this in, and we are done. So it's quite simple. I will probably increase this casing length so that it covers the whole motor and it doesn't leave it exposed like this. It will be updated in the CAD files I will be sharing. Now let's test it. So I have my old phone here. It's completely dead, as you can see. Holding the power button doesn't turn it on. So let's see if the battery symbol comes on when we crank it for a while. I will not speed up the video so you can see actually how much time it's going to take for the phone to register the charging being done. As you can see, it has lit up. So this isn't fast. It's not meant to replace a power bank. But in a real emergency, even a few percentage of battery can matter. This build is simple, compact, and completely independent. That's what makes it useful. And if you enjoy practical DIY projects like this, especially the ones that actually work, consider subscribing. I focus on honest builds, not gimmicks. Thanks for watching.